Hello and welcome back. In this lecture, we're going to talk about JavaScript from a definition standpoint. What is JavaScript? So in order to do that, we're going to go to Atom, and inside the chapter 1 file, you'll see a what is markdown file, and this has the technical and the non-technical definition. Now, from a non-technical standpoint, I tend to divide languages into two types, pragmatic languages and opinionated languages. And a pragmatic language is a language like PHP or JavaScript or C++. And these languages do not tell you how you should go about solving a problem. They leave it completely up to you. The downside of languages like this is that there are different coding standards, there's different conventions, and whenever you jump between different C++ or PHP projects, how they solve the problem can be wildly different. So each time you have to go through the code and try to understand how it works. Opinionated languages are languages which try to maintain internal consistency in terms of names, in terms of structure, and in terms of how they solve problems. You'll often hear in opinionated languages the term convention over configuration, which means that there should be a well-defined set of standards for how you solve a problem, and that individual configuration should be discouraged as much as possible. Languages like this are Ruby, Java, and Python. Now, the downside to these sorts of languages is that if you disagree with the convention, there's nothing you can do about it. And Java is probably on that list the one that's most notorious. And the problem with Java is that it's incredibly verbose to write even a simple hello world program. And JavaScript is the premier pragmatic language. It was created in 10 days by Brendan Eich, and that wasn't a choice. He had that deadline. And the fact that JavaScript has problems isn't surprising even to him. What's amazing is how good JavaScript is given all the limitations that were put upon it. So then we get into the technical definition. And the technical definition of JavaScript is that it's a high-level, dynamic, untyped, coercive, single-threaded, synchronous, and interpreted programming language. So to run through what all that means, a high-level language is a language that doesn't deal with memory management or deal with the hardware or things like that. It doesn't deal with GPU. You simply write the program and the high-level language will figure out what it needs to call in order to make that work. The low-level languages are languages like assembly, which you have to push bits in and out of memory and you have to maintain state. JavaScript isn't like that. Dynamic means that you can declare variables at runtime and you don't have to specify what type of variable it is. So for example, in Java, if you want to create a string, you have to first say string, and then the name of whatever you call that variable, so my string, then you have to set it equal to a new string, and then what the value of that is. And you see the same thing with integer. In contrast, the only thing you have to do in JavaScript is declare that you're going to be creating a variable with the keyword var, and then it can be a string, it can be an integer, it can be anything it wants to be. Although technically JavaScript doesn't have integers, it just has numbers. Then untyped, and that means that there's something called type hinting, which means that you say what something is, and JavaScript has no support for type hinting whatsoever. But famously, TypeScript, which is a superset of JavaScript, it does have this ability. And type hinting tends to be very important when you start writing larger applications, because otherwise you don't know what's getting passed around to your functions, and this can be very hard to keep track of, and it can lead to a lot of bugs that you have to track down. Now, coercive is probably the thing that most programmers hate about JavaScript. Having an untyped language and having a dynamic language aren't really problems. For example, Python is a dynamic, untyped language. You can just declare variables and use them. But JavaScript will attempt to coerce invalid types into each other. Python does not do this. Python requires what's known as type casting, whereas whenever a language coerces a value, it's known as type juggling. And there's a very famous lecture called WAT, W-A-T, WAT, as the guy will say it, that goes into all the problems that are caused by these weird coercions. Next is single-threaded, and that means that only one thread of execution is happening at any time, and this limits any language that is single-threaded. It can't perform intensive processes. So being able to process audio, for example, takes a lot of CPU processes. So in order to get around this, on the web they added what are called workers, which are background operations that work multi-threaded. And then on the server side, you have child processes with Node. And what that does, it spins up a new Node instance, it performs the task, and then it shuts it down as soon as it's finished. So this is what I mean by JavaScript being a pragmatic language. Yes, it's single-threaded, but it has solutions which are kind of hacky, but they are valid solutions for getting around the problem. Likewise, JavaScript is synchronous, and that means that whenever one block of code is executing, no other block of code is executing at the same time. The most famous way you can see this is with what is the most annoying thing in JavaScript, which is the good old alert. So while that alert is there, notice that I'm clicking around, I'm trying to click on different pieces of the page, and absolutely nothing is going on. This is what's known as synchronous blocking. So while this is running, I'm not allowed to do anything else on the page. So I have to click OK. Likewise, if I do prompt, you can see here that while that's there, I can't do anything else. So these are incredibly annoying. And the way that programmers decide to get around this problem, or JavaScript in particular, is it has what's called an event loop. The event loop is complicated. It's not really that complicated, but it would take a bit more time than we'd have in an introductory course to get into it. So John Resick has a blog, and he's the inventor of jQuery, and he explains sort of how it works. And when you look at the diagram, basically what happens is that each time an event occurs in the event loop is that it registers that, yes, you clicked on a mouse at this point, and then some other things are going on. The next thing that happened according to this event loop is that the clickback occurred. Then the interval fires, and now we're into the timer, and then the other pieces keep executing. So this is sort of like a queue. As events occur, they line up one after the other. As soon as one is done, another one executes. And that's how JavaScript gets around that problem. And right now, for example, if you attempt to execute synchronous AJAX calls, Google Chrome will send out a little warning saying, please stop doing that. And just so we can see what that looks like, you can see right here it has this little triangle, a little danger sign saying stop doing that. And then if we do console.error, that shows you what it looks like whenever something actually goes wrong. So this is just Chrome trying to warn you that synchronous code is bad. Usually if you keep doing alert boxes, it'll give you this dialog saying prevent this page from doing it, because Chrome knows that this is really annoying. And then finally we have interpreted. And once again, there's another caveat with this one. A true interpreted language is like writing bash shell scripts. And when you write a shell script, if you're on line 2, the shell script has no idea there is a line 3 until it occurs. These types of languages that are strictly interpreted are very, very slow. JavaScript uses what's known as a JIT, which is a just-in-time compilation. And that means it has 2 passes. In the first pass, it attempts to compile all that it can and figure out how the code's going to work. And then the second one, it does a runtime pass, which is where anything that it cannot figure out from the compile time pass, it runs. And you're going to see the importance of that when we get to errors and variable hoisting, because anything that happens in the compilation pass, if there's an error thrown, you can't catch it. It'll just crash your program and it'll stop execution. So that is an overview of what JavaScript is from a definition standpoint. From a non-definition standpoint, JavaScript is one of the most popular languages that exists right now. You can see it all over the place. We're running Atom, which is running JavaScript. We're running it on the web. We're running it on the server with Node. There's databases like MongoDB that are written in JavaScript. So JavaScript is all over the place right now. In summary, what we've looked at is the definitions of JavaScript.